Okay, when we're talking about torque and rotational equilibrium, we're going to be doing something familiar, which is drawing free body diagrams. We are going to have to change it up a little bit. When we're drawing these free body diagrams, it's really important where the forces are acting. And so we want to make sure that we include that information of where they're acting on our free body diagram. And so what we're going to do is we're going to call it a rigid body free body diagram. So instead of representing the object as a point, we're going to represent the object as a rigid body. Could be a line or a rectangle or something to represent the shape of the object. In this case, we are analyzing this part of the crane here. It goes from here down here. So that part right there is what we're analyzing. That's our object of interest. And we're simplifying it and just representing it as a single line here. And so we look, where does this object that we've put here, where does it interact with the world around it? And so we want to think about those places where it interacts. And so on here you can see those are selected with dashed lines. And so right here, dashed line, and right here, that's where it's interacting with the world. And so the forces that are acting on that boom, as many people would call it, it has weight. And then down at the bottom, where it's attached here, there is a vertical support and a horizontal support. And that's something that is good to recognize, is that most of the time when something's pushing up against something else or attached to it, that there's forces in two directions, upward and, well, vertically and horizontally, not necessarily upwards. Then at the top, there's a cable going this way, and so there's a tension force, capital T, and then there's a cable going down, and so there's a tension there as well. So we want to be able to draw rigid body, free body diagrams, and all of these steps are in your note packet, and so I'm not going to read through them, but let's do some examples. So we're instructed to draw a free body diagram for this beam that is right here. So we're going to draw that over here as best we can. Okay, might not have gotten the angle perfect, but that's the thing that we're analyzing. The beam has weight. You don't want to forget that the thing itself has weight. There's the weight of the sign. And so since I have that on there, I'm going to call this the weight of the beam. There is a tension which appears to be perpendicular to the beam, and it's not in the center, it's above center. So the weight of the beam is right in the center, and this tension is above center. Call that capital T, not tau, but just a regular capital T. And then over here we've got a horizontal force. Okay, so I could call it F sub H, or R sub X is another name that's commonly given to that. And the reason that I know it's to the right is because if I look at all of the other forces, I see that tension is acting partly to the left, and then nothing else is acting horizontally. So there has to be something pushing to the right. The vertical direction is a little trickier, but probably this is acting upwards, and so we could call this F vertical, or we could call it R sub Y. And that's our free body diagram. Here's a simple one, the second example. We've got a beam, it has weight, and it has a support force or normal force. Okay. Here another fairly simple example. Trying to draw this as a horizontal line, but it has a normal force and weight straight down, and it has a force right here. This is the weight of box 2, and here we have the weight of box 1. And I just called them 1 and 2 just so that you would know. And then up here we've got another one. And one thing to point out is that I'm drawing the object of interest, this beam or board. I'm not drawing in the forces here and here and here. I mean, you can sketch them on there to get a feel for it, but this is where you want to draw your actual free body diagram as a separate entity. So there's the weight of the, we'll call it the weight of the beam. I forgot to put that in here on these diagrams. The weight of the beam. And then we've got an extra big, this is the weight of 2 boxes. And then over here, weight of other box. I mean, you know, what we call these is not super important as long as you can tell them apart. And then the last thing, if I look at this, this definitely looks wrong because there's no upward force. There's going to be a normal force upward. And if I were drawing this to scale, this force that I just drew would have to be equal to this plus this plus this. And I don't have room to do that, but if I needed to draw it to scale, I'd want to make sure to do that. And let's stop there, and I'll pick up in the next video